Hey again, it's Mr. Lum, and in Chemistry 11, for this lesson, we're going to be talking about chemical changes and physical change. So the first one we're going to cover right here is chemical change, and this is when one chemical is changed into a new chemical substance. So the example I put up here is when we have magnesium reacting with oxygen, making magnesium oxide. We will do this demonstration in class where we take a very shiny metal and we're going to burn it, and it's going to make this kind of grayish powder at the end. And this is an example of a chemical reaction. The reactants are going to have completely different properties than the products. So magnesium is going to have a certain melting point, a certain boiling point. Oxygen also has a certain boiling point as well. And magnesium oxide is going to have a melting point and a boiling point that is completely different from oxygen gas and magnesium solid metal. Okay, so it's going to have these are all going to have completely different properties from one another. Now, in a physical change is just simply usually a change of state or phase. Now, you can take an object and crush it up and change it and deform it. That's and also another type of physical change. But the physical change that we're going to be talking about right now is when an object is melted and then maybe turned into liquid and then turned into gas after that. So an example, a very common example, is when you have something like water or H2O. It could start off as ice, then melt and become water, and then boil and become steam. So what we have here is an example of a graph that shows how a physical change may happen. So at this point, when the temperature, so here's temperature on the y-axis, and on the x-axis, this is just energy added. So energy added. And again, T temperature, this is the temperature of our material that we're adding energy to. So if this was way down here, right here it's going to be a solid in between this point down here and this point right here. So if this was for water, for example, this would be ice down here. Now, once it gets to this point right here, it's going to be solid and liquid. And you've seen that before, where we have an ice cube, and it's reaches a certain point where half the ice cube is still ice and the other half of it has turned into water. And so if it's half ice and half water, that'd be somewhere right about here, at this point right here. Half of it's still solid and the other half is still liquid. And then once it completely melts, the temperature starts to go up again, and then it can be, well, then it is a liquid. And the temperature is going up in the liquid. Okay, so right here, if we're using water for an example, right here might be 1 degree way down here, and it's going up and up and up and up and up, and then it starts to get to a certain temperature where it's at 100 degrees, or in other words, the water is boiling and it's starting to evaporate off, and so we're getting some liquid at this point, and maybe half of it has evaporated off. So again, we're in the middle point right here, and the other part is gas. It has all gone out. And then above here, it is all just gas. It is all boiled off, and that gas can continue to get hotter and hotter as more energy is added, and it gets hotter and hotter. Okay, So what can we interpret from this graph right here? Well, what we can see here is that at this point, when it's in between solid and liquid, so in other words, right there, when it's in between solid and liquid, this is what we are going to be our melting and freezing point. So if energy is being added to it, well, this is probably going to be our melting point. If energy is being taken away from it, it's going to be our freezing point. So our melting and freezing point are actually the same place. So you can think of it, it just depends on the direction in which you're going. So again, if energy is being added to it, this is the temperature at which it's melting. If energy is being taken away from it, this is the temperature at which it starts to freeze. So again, this is our melting and freezing point. Now, at this temperature right here, when it's going from liquid to gas, again, if energy is being added to it, this is our boiling point. Okay, so this is our boiling point when energy is being added to liquid and it starts to turn into gas. And if we have a gas and energy is being taken away, well, this is our condensation point. Okay, so this is the same temperature right here. So again, if we were dealing with water, this number right here on the graph, at temperature right here, that would be 100, and this number way down here would be 0. Okay, so you can have H2O that is above 100 degrees. It's just going to be usually in this gas form right here, or steam. You can have H2O that's below 0, right down here. Okay, and it's just going to be all solid, though, all ice. Okay, so we'll be looking and doing this experiment in class using a different substance rather than water, which we all know what the melting and boiling points are for that. We'll be using para-dichlorobenzene. Okay, so most of you in class are not familiar with that, so we're going to figure out what is the melting point of para-dichlorobenzene in class, and we'll be using thermometers and figuring out exactly at what point is this right here, and you're going to make this little graph right here. Okay. Now, sometimes for certain chemicals, you could have it going from solid, and then it just goes straight to gas and skips this whole liquid stage right here. Okay, it just goes from solid to gas, and what we call that is sublimation. Okay, so sublimation is when you go from solid to gas. Okay, again, it's a physical change. So we're not reacting two solids to make a gas. Okay, we're just going from one substance, going from solid to gas, and that's called sublimation. So a very classic example of sublimation is caffeine. Caffeine, often when you have solid caffeine and you start to heat caffeine up to a certain temperature, it kind of just evaporates right away and turns into gas. Another one that does this as well is dry ice. We have carbon dioxide that just goes from solid and straight to gas. Now when we have the opposite of that, when it's going the other direction, it's called deposition. And that's when you go gas back to solid. Again, skipping that liquid phase right there. Okay. A little bit more rare. This is kind of more of our classic example right here, but something that we definitely need to know. Now, when a physical change is happening and say something is turning from a solid into a liquid, into a gas, energy is being added, and the energy is usually in one of these three types. There's vibrational kinetic energy, rotational kinetic energy, and translational kinetic energy. Okay, so here's a picture of different types of vibrational kinetic energy, and what it is just the bonds are just kind of bending or stretching, and here's just a different way of it that it's stretching right here. So vibrational is kind of bonds stretching and moving. Rotational is when the molecule just kind of spins. And translational, it's just moving. The molecule is just simply moving from one location to another. So what I want you to do for your homework, and we'll discuss this in class, is read the textbook and figure out at what kind of energies during, say, when it's at the melting point, what kind of energies are most prevalent when a solid is turning into a liquid, and also when a liquid is turning into a gas. And we'll discuss that in class. Okay? Bye.